Okay, today we're going to be talking about solving radical equations. There's a couple of steps to solve these. The first thing you always want to do is isolate the radical on one side of the equal sign. So make sure that the only thing on one side of your equal sign is the radical. Then you're going to raise both sides of the equation to whatever your index is. So if you had something to the 1/3 power, you're going to cube it. If it was to the 1/4, you'll raise it to the 4th power. That will cause your radical and the exponent to cancel, and then you solve the final equation. A couple of things to make sure you're aware of. You always need to check your answers when we're solving radical equations. This is similar to with the absolute value equations. Occasionally you will get an answer and it will not work in the original equation. That's called an extraneous solution. So remember that word, extraneous solution. So that will definitely happen with radicals. Also, if you ever have an even radical, so something to the square root or the 4th root, those will not be solvable if it equals a negative number. And we'll do some of those so you can see. Okay, so our first one, square root of x equals 6. The radical is by itself, and that is to the 1/2 power, so I need to raise it to the 2nd power. So the radical and the 2 cancel, and I get x is equal to 36. Okay, and let's just double check it over here. Does the square root of 36 equal 6? Square root of 36, notice there's no sign there, so we assume the positive. So the positive square root of 36 is 6. 6 equals 6. That's a good solution. Okay. Second one, radical is already by itself and it's to the 1/2 power, so we square it. Those will cancel, giving us y minus 5 equals 3 squared is 9. Now to solve this, we have to add 5 to both sides, and we have y is equal to 14. Plug it back into the original equation. So 14 minus 5 square root, does that equal 3? 14 minus 5 is 9, square rooted. Square root of 9 is 3. And 3 certainly equals 3. So my solution of y equals 14 is good. Okay. We've already got our radical by itself. So let's go ahead and square both sides. And we get 6p minus 5 is equal to 25. Add 5, and we have 6p is equal to 30. Divide both sides by 6, and we have p is equal to 5. Now we want to plug that back in. So over here I'm going to just check it. So 6 times 5 minus 5 square rooted, does that equal negative 5? 6 times 5 is 30, minus 5 is 25. So does the square root of 25 equal negative 5? Remember, we take the positive here. So does 5 equal negative 5? No, it does not. So this means p equals 5 is extraneous. So there is no real solution to this problem. We also could have recognized that in that we had the square root equal to something negative. So there's no need to do all this work if you have it set up like that. You can just declare there is no solution. But I wanted you to see what happened. Okay, the cubed root of 9w equals 3. I need to raise this one to the 3rd power this time. The cubed and the cubed root cancel, so we have 9w equal 3 to the 3rd power is 27. Divide both sides by 9, and we have w is equal to 3. We want to plug that back in, so the cubed root of 9 times 3, does that equal 3? 9 times 3 is 27. The cubed root of 27 is 3. 3 equals 3, so we're good. Our solution is w equals 3. And this was kind of an unusual one in that our solution is equal to the value on the right. But it's not because these two things are the same, it's because the left and the right here are equal to each other that it's correct. Okay, Again, a cubed root, so we need to raise it to the third power. So 1/3 times 3 gives us 1, so 7m plus 20 equals 5 to the third power is 125. Subtract 20, and we get 7m is equal to 105. Okay, divide both sides by 7, and we have m is equal to 15. And of course, our last step is always go back and plug it back in to make sure it works. So does the cubed root of 7 times 15 plus 20 equal 5? That's what we're checking over here. 7 times 15, I think I just want to double check what that is. 105 plus 20 is 125. Cubed root of 125 is 5. So 5 equals 5. Our solution is m equals 15. Let's do a couple more. Okay, this one it looks like we need to do some work before we can start solving it. So 5x minus 2 to the 1/3 power plus 3 equals 0. Remember, I have to have the radical, or in this case the exponent, by itself on one side of the equation. So I need to subtract 3 before I can raise it to the power to get rid of the exponent. So I'm going to have 5x minus 2 to the 1/3 power equals negative 3. Raise both sides to the third power. So I have 5x minus 2 equals negative 3 raised to the third power is negative 27. Add 2. 5x equals negative 25. Divide by 5, and we have x equals a negative 5. And of course, we're going to plug that back in to make sure it works. So 5 times a negative 5 minus 2 to the 1/3 plus 3, does that equal 0? Oops, let's make it so you can see. 5 times negative 5 is negative 25, minus 2 is a negative 27 to the 1/3. The cubed root of negative 27 is negative 3, so negative 3 plus 3 is 0. So 0 does equal 0, so x equals negative 5 is my solution to that problem. Okay, one last problem, and sorry, I've kind of written all around it. But again, we need to do some work before we can raise this to the power. We've got to have the radical by itself. So I need to add 2 to both sides. So I have 4 times the square root. I'm going to call this x so you can make sure and see what variable I'm using. So 4 times the square root of x equals 12. Okay. Okay, let's divide both sides by 4. So we have the square root of x equals 3. And now we're going to square both sides because I've got the radical by itself. So x is equal to 9. And again, let's plug that back in over here. So does 4 times the square root of 9 minus 2 equal 10? I'm just putting a question mark there because we're not sure yet. Square root of 9 is 3. 3 times 4 is 12. 12 minus 2 is 10, which again tells us x equals 9 is a good solution to our problem. Okay, let's take a look at the next side. Just a couple more problems. Make sure we're comfortable with these. Okay, in the case where you have two radicals, you want to have one on each side of the equation. And we just go straight to raising them to the power that is needed. These are both square roots, so we're going to square both sides, which just causes our radical signs to go away. So we have 3x plus 1 is equal to 2x plus 7. That looks good. Now, just basic algebra, need the x's together, so let's subtract the 2x and then subtract the 1. Those will cancel, and we have x is equal to 6. Okay, need to double check. So 3 times 6 plus 1 square root. Does that equal 2 times 6 plus 7 square root? 3 times 6 is 18 plus 1 is 19. This is a question mark. 2 times 6 is 12 plus 7 is 19. Yep, the square root of 19 is the square root of 19. So x equals 6 is our solution to that problem. Okay, one more where we do have to do a bit of work before doing anything else. I need the radical by itself. So let's add 5 to both sides. And we get the square root of 1 minus 4x is equal to x plus 5. Okay, we need to square both sides. And remember, I cannot distribute that exponent to things that are added or subtracted together. I actually am going to have to multiply this part out. But on the left side, they just cancel. So we have 1 minus 4x is equal to, so x plus 5 times x plus 5. You can do this with FOIL, you can do it with a box, or you can even do it in your head. But I'm just showing it here so everyone sees where I get my terms. So this equals x squared plus 10x plus 25. Okay, quadratic. So we're going to have to be doing some factoring, or maybe even the quadratic formula. Let's figure this out. Okay, so we need to get everything on one side of the equation. So I'm going to subtract 1 from both sides. I'm going to add 4x to both sides. So now I have 0 is equal to x squared plus 14x plus 24. Okay. So I need things that multiply to give me 1 times 24, but add to 14. So 12 and 2, those equal 0. If I solve each of these factors for x, I get x equals negative 12, x equals a negative 2. Okay, 2 answers this time. So that means we have to check both of them in the original equation. And I'm actually going to do this lower down on the page just so you can see what I'm doing. So we had the square root of 1 minus 4 times x. So I'm going to put in the negative 12 there. Minus 5, does that equal x, negative 12? Negative 4 times negative 12 is positive 48 plus 1 is 49. So square root of 49 is 7. 7 minus 4, or minus 5, that is equal to 2. 2 does not equal negative 12. So that tells me that negative 12 was extraneous. So extraneous. So let's try the negative 2 now. And again, I'm going to do this down here on the bottom of the page. So 1 minus 4 times a negative 2, square rooted, minus 5, does that equal a negative 2? Okay, let's take a look. Negative 4 times negative 2 is a positive 8, plus 1 is 9, minus 5, does that equal a negative 2? I guess I should have that question mark in there because we're not sure yet. Square root of 9 is 3. 3 minus 5 is negative 2. So that tells me my solution of negative 2 was good. So I have one good solution and I had one extraneous solution. Okay, let's go on to our last 2 equations here. And these are both formulas. Let's see if you recognize what they might be for. So this one, v equals square root of a times r. I want to solve for a. So a is under the radical, and my radical is by itself. I can go ahead and just square both sides. So v squared is equal to a times r. I need a by itself, so let's divide both sides by r. And I get a, which I just switched to the other side, is v squared divided by r. So I'm guessing that's probably a volume and a radius. Okay, let's take a look at this one. R is equal to the cubed root of 3v over 4 pi. Ooh, pi. We want to solve for v. Okay, and again, that's under the radical sign, but the radical sign's by itself. So I need to raise both sides to the index, so to the third power. So now I have r cubed is equal to, those cancel, 3v over 4 pi. Okay, my goal is to get v by itself, so I need to multiply both sides by 4 pi, or 4 pi over 1. So those will cancel. So now I have 4 pi r cubed is equal to 3v. Divide both sides by 3, and I've got v is equal to 4 pi r cubed divided by 3. You might recognize that. That's the equation for finding the volume of a sphere. Okay? Okay, again, be very careful doing homework. Make sure you plug your answers back into the equation to make sure you don't have any extraneous solutions. Step 1, get the radical by itself, raise it to the power, solve for your variable, and then plug it back in. Good luck.